we're going to be working on more Nodebot stuff. Specifically, we're going to continue work on my silly capsule toy machine. Let me show you down there. Capsule toy machine monstrosity that has some Node.js, Nodebotsy stuff in it. Let me tell you a little bit more about it. So let me switch over to live view. Okay, so here's a web browser. Oh my gosh. And there is a game. It is called Ingress. You play it on your phone. And it's kind of like a capture the flag game where the flags are pieces of public artwork. Okay, kind of like Pokemon Go, but with kind of a cyberpunk story to it. And there was an event. A live event. They have lots of in-person competitions. And one of the in-person competitions had a call for artistic proposals for installation art. And I created a piece of installation art. Here it is. It goes between the two different teams, green and blue, and it reacts to physical event, or rather it physically manifests events that occur in the game. And it was fun. The event is long over though. But it is time to bring our project back out because there's a new party coming up. There's a local event in that game happening. And they would like some of the physical art installations from the previous event to make an appearance at the party this weekend, actually. So this weekend, I wanted to bring it, but it used a special API to do the blue-green transitions before, reacting to an in-game event. That API is gone. But I still want it to work and I still want it to be fun. So basically what I'm doing is I'm doing some refactoring. I'm tidying up some of the mess I created, and I'm installing a toggle switch override so that when the API is not available and it can't react to the gameplay, you can still see it transition through its state changes. So pretty simple stuff. This is the second stream in a series on this. So if you'd like to see more, check out my YouTube linked below, and you can see my previous work on this project. So let's pick up where we left off last week. Here's my to-do list. So one thing I did on my own was to physically install another toggle switch into the actual art project, because I did a lot of my work from a little development board right here, which is kind of like a model of all of the electronics that's in this thing. It's just easier to work with on my desk. It also has fewer LEDs, so I don't have to worry as much about massive power consumption and heating of the room I'm hacking in. So yeah, so we'll continue work on that. Boop. We're going to do some more refactoring. The code in there is a mess, because all code is a mess. At least all code I work on seems to be a mess. But anyway, I want to consider doing a refactoring using a big old state machine. And then I also want to write a management application, and I want to spend some time tinkering around with Vue.js because it is a framework I would like to learn, and a great way to learn frameworks is to use them in action. So what I want to do is I want to be able to enable and disable the toggle switch. I want to be able to change the sparkliness of the lighting, as well as the animation speed, maybe the brightness, as well as the amount of color variation. So basically I want to do a bunch of visual things so it still looks visually interesting regardless of the lighting it is involved in. There's one other thing I want to do is electronics refactoring. I want to rewire I actually have to wire up the switch. So let me just do some electronics tinkering. So electronics refactoring. So a couple things I want to do. I want to wire up the switch I added to the actual art project, the actual artwork. I also want to fix there's a continuous servo that it uses to dispense the toys, and that is broken. It got broken by me futzing with it. So fix the wire for the servo motor, which is kind of sad because it's kind of a disaster in there, because I hacked it together rapidly, of course, as is the case with all these things. Get it working, and sometimes that's all you get to, and then it's time to do the show. And it performed fine during the event, so it was good enough. So let's get started with that. So we're gonna wire up the toggle switch. So I'm gonna pull up, first of all, I'm gonna see if my little document projector can see the inside of that machine okay. So I'm gonna add another, oh, the dock projector's already on there. I'm gonna add the dock projector back in. So I have another camera, which I'm setting up now. Here it is. Right now it's showing a picture of my desk. Not very exciting, but I can use it to tinker around with electronics. And if this works out, I can also use it to show you the contents of the kind of heavy project here. Let's see how well that works. So what's going on in here now? Where is that toggle switch? It's on the other side. So will this actually work, or do I need to? This is the fun part where I spend some time trying to position the camera so you can actually see it. It's upside down. Right side up. Okay, that actually works okay. I'm not as horrified as I thought I would be by that. But it's not very wide angle. So, well, let's do it anyway. So let me stick my to-do list over here. Whoop. And yes, if you're watching on chat, please do chat with me. It does make it a lot more fun when someone actually talks to me. That's not terrible. I think more lighting would probably help. So let me bring on some lighting. Boop. Let me see if I can get my... I have this nice work light. Let's see if I can get it to actually shine into there. That kind of works. That's a little better. Okay. So you can actually kind of see in there. There's a toggle switch up here. It has 6 different little positions because it's one of those toggle switches you can use for all sorts of stuff. I'm using it in a much reduced capacity. There is an Arduino Uno back here. Based on my development board, I want to wire it up to which pin? So I want the this wired up to pin 6. So I'm going to wire up the toggle switch to pin 6. And I need to grab some wire because I have some wire sitting over around the other side of the room. So I will be right back. I think it took me more time to get my headset on and off than it did to get that together. So let's go ahead and put some wire on there. So it's the way toggle switches work is they switch in the opposite. Like the switch right now is pointed up, which means it's connecting. These 2 bottom pins are connected right now. Actually, there's another set of pins behind it that are also connected, but I'm only going to be using the front ones, or I guess, yeah, so you can actually see it. And when I switch it the other way, the 2 different pins, the top 2 pins are connected together. So what I can do is I can put the signal read in the middle, put ground on one side and voltage in on the other side, and have that so that it's either doing voltage in or it's doing ground. So it'll be easy to see the toggles going back and forth. So I'm going to go ahead and do that. So I need, and I'm just using some solid core wire to do that today. Normally I'd like make a fancy connector or something, but I think this will be fine. So I need a few different wires. I need a good length of them. I'm going to pull out of my little patch wire kit. I always tend to pull a little more wire than I think I'll probably need. And I'm just going to jam these right into the headers in the Arduino because that's what's there now. If I wanted this to actually be serviceable, I'd probably at least make a little perf board shield type thing. You know, one of those Arduino shield. Those little perf board Arduino shield kits are kind of nice for getting something that can be, you know, so you can swap out that Arduino board in one go instead of futzing around. So I'm just making a length of wire, three conductors on it, one for ground, one for the voltage input, and one for the signal that goes back to the board. And I'm just going to twist them all together. Just gonna hand twist. This is something, if it was long enough, I'd just use a power drill for, but a hand twist works for now. Another thing you can do is if you just need a couple pre-twisted solid core wires is if you're gonna throw out an Ethernet cord anyway, there's pre-twisted solid core wire in there, which can be kind of useful for doing projects like these. Especially if you have like an old Cat 3 or Cat 5 cable that you're going to throw out, because it's no longer super duper shiny Cat 6, Cat 6A, whatever is currently being wired, buildings being wired with. There's not something you can continue to use. You can scavenge components from it. This is a great way for silly projects like this. Okay, so I have 3 different wires here. I'm going to kind of put a little like hook shape on them so I can hook them onto those screws. And then I will move my keyboard aside so I can actually see in there while we screw it down. What's kind of nice about this toggle switch is for whatever reason it has little screws on there, so I don't have to make a little quick release adapter or anything for it like this little spade. So we have, I need ground on bottom, voltage on top, and that and that. So I'm going to put a little hook in each one of these. So I'll just wrap it around a screwdriver. Should have a little too much conductor, so I'm going to trim them down a little bit more. This is the fun part of the development. You actually get to play with stuff. One of the funny things is, despite having essentially half of an electrical engineering degree, this is the kind of stuff you don't really pick up in the schooling. So I am sure I'm making tons of mistakes on all this stuff, because I learn everything the way I learn anything else from YouTube videos. So if you ever see me do something profoundly dumb, please let me know. Be civil, but definitely do let me know. Because that is how I learn, and that is half the reason I'm doing a stream like this, is so I can learn things. Okay, so we have little tiny hooks there, which are out of focus, but make it a little bit easier to kind of latch on to these things. So I'm going to go, take my screwdriver, unscrew these 3 things. And then squish them in place. Boop. And actually, I think the extra conductor I had trimmed off is probably fine, because now I have the little insulations kind of getting in there, which is not great. So I have, oops, that one's not quite getting there. Get on there, you. There we go. That feels like a better connection. Oh, nope, not. I guess not. Maybe it would be easier if I just pulled off the screws and did a little quick release connector or something like that. Okay, one more, which is the one that goes down here. Let's round that out a little more with the screwdriver head. So the upside of solid core wire is it's really easy to work with on projects like this. The downside is that it's brittle. So if it gets shaken a lot, it's probably going to break. But I don't expect that to happen much on this project. Okay, I'm actually gonna strip out a longer little section of wire. Oh wow, little. Get a big old hook around that screw. And then screw it in place. But usually the first thing you'll encounter if you're doing kind of the hobby-ish hacking around stuff is the solid core wire, because it's what comes in your little jumper kit. Although sometimes the pre-made jumper kits have stranded core stuff. Like I think there's some, yeah, this wire is stranded core. Which is nice and flexible, but kind of a pain to work with because it does not stay put. Okay, so let's verify that this thing actually works. So I'm gonna pull out my trusty multimeter, poop. There we go, right here. We're gonna do continuity checking, which is when it makes a little beep noise when you touch it to a complete circuit. So now I would expect, since the toggle switch is currently pointed down. Ooh, get that on camera. So the toggle switch is currently pointed down. I'd expect the white and the red to be conducting. Let's see if I successfully made that connection. It's kind of like running your code every once in a while. You got to check to make sure you didn't screw up something basic like wires touching each other. And hey, they have continuity. I expect the black one to not have continuity and white to black to not. Okay, so if I switch it up, I would expect white and black, but not red and white or red and black. Great. And it's important that red and black don't touch each other because that would be a short and that would make my Arduino turn off. It would make other things die, but Arduinos are basically indestructible. I know I've read a blog post about how to destroy them, but they are far more durable than other things I've worked with in the past. So now we wanted to plug this into pin 6. So, I have power distribution, so I need to get a 5-volt signal. And I already have, I have a power supply that is, was it pushing power to the Arduino into the, oh no, it's coming around USB. Okay. So I already have this, there's a little power supply I'm using, and it's actually on a hat on the Raspberry Pi, which I think I originally got for controlling like LED panels. But I repurposed it for this project because it's also like, you know, it has a pretty high current 5-volt power supply, which is enough to power all these LEDs. So I want to use the same 5-volt signal for this switch. So I'm just going to connect that into there. So I need a tiny flat screwdriver to get that open so I can shove that wire into there. And then I'll need a tiny flat screwdriver to shove the ground into there, and then I'll need the white wire to go to pin 6. So this white one here is going to the LED strip, and then this one's also, this is the broken one I was talking about. The little tip broke off, so I'll probably just splice on a piece of wire because I don't really want to solder in this room. Yep, and then I need to get this onto there. And then when the toggle switch switches, the pin 6 will see a change from high to low. So I'm going to go grab a tiny screwdriver to open up there's a little kind of nut up here, which you can't really see because it's being blocked by all the things. It's very hard to get a camera inside an enclosed project. So I'll be right back. I'm gonna grab a screwdriver. Hello, I'm back. So let me actually make this even bigger. There's really no reason for you to see my desktop right now. So let me send it to the back, move to bottom. There we go. Nope. I moved it too far down. I just screwed up the order on all these things. There we go. There. Okay, so now my little webcam was above that. Okay, but this is still bigger. So I'm going to hook that up. So there is a little tiny, let me just turn this whole thing around. Yeah. Let me see if I can get it to focus. Great. So there's a Pi here, which usually runs all the Node.js code. There is, and then has this hat on here is a power distributor. Like it's actually an LED controller hat for LED panels, which I was originally going to use on this project, but I decided to nix that part of it. And then it has format is running on this Arduino, but I'm still using this for the power supply because it's awesome. So I'm going to go ahead and add in another wire to my big ol' mess of power wires I have here, which is kind of a tangle right now. Might take this opportunity to untangle this mess. How did I do this? Yeah, so I twisted together all these things. And they're actually like intertwined right now. So pull that out. Actually, I guess I have to untwist it. So I don't really have, I have these big old wire cutters, which I can probably use to shake it apart. I don't have any tiny pliers with me. Oh, it's starting to come apart. There's one. Two. And the last two. So now I can untwist some of this mess. There we go. Okay, so they're not all tangled together anymore. So I'll twist all those back together, and this one kind of keeps the common ground plane, or common ground between the Arduino and the Pi. This one goes off to the LED strips for power, and it has a capacitor in it to keep it from burning out the LED strips. Even though it is regulated power, I always do that. Stick a cap in there. This one goes off to the other side of the LED strip. Because I'm driving power into both ends because it's a pretty long strip. It's like 100, this is like 190 little neopixels long. So you get less drop over the length of the strip if you just put it in both ends. And if you have a long enough one, you start putting in power in, in the middle. And then we have the new one, which is for the toggle switch. What's a bummer is that I have to do this every single time, which makes me wonder if there's a better way. Because if I'd actually done a little board up here, like a little piece of perf board, I could just add these to that. I mean, I could stick a mini breadboard in there and then just do it off the mini breadboard. And I have taken this apart a couple times. I wonder how much power I can safely put through a mini breadboard. Well, one way to find out. I may end up doing that. But then it will be really sensitive to getting shaken apart, which is not something I really would like. I'll probably still do the same kind of twisted up bundle of wire approach. Yeah, let's go ahead and do that. So Let's take apart the red one also. And then I have a broken conductor from the servo motor that I need to fix also. Okay, so downside is every time I want to add a wire to this mess, I have to take it all apart, twist them all back together, and this is probably the last thing I'll add to this particular project. It was a fun project, but it's more fun to move on to new green pastures. Go ahead and straighten these out using this very appropriate tool. If anything can smash these. I don't have any. I wish I had some pliers with me. All I have is wire cutters for some reason. I have like 3 kinds of wire cutter and 1 kind of wire stripper on my desk right now. But I'm going to need pliers anyway to do the twist. So I'm going to go grab another tool. I will be right back. Boop. Boop. And I'm back. I grabbed some pliers and a forceps, little, you know, surgical thing. And so let's go ahead and squish these flat again. I wonder how many times they can take this being, you know, like twisted and untwisted before they just kind of like fall apart. Go ahead, get all these bundled up. And then, sorry to pull away from the camera, but it's just, there we go. I'm kind of keeping you in frame there. It is just, sometimes it's hard to work at right angles, which is essentially what I have to do to keep you in frame. So twisting this monstrosity together. Then I'll trim the tip off. And put it back in here and screw it down. And the hard part, actually I wonder if I can take this whole thing off. I'm gonna try that. So let me take the sheets of polycarbonate off, so it makes a little less noise while I do that. And then, how much of that, because it's actually hard to see the board while I'm working on it. I think it's a little better. At least I can see kind of straight down into there. But basically what I'm having trouble seeing is I'm having trouble seeing the pins that I'm working with. But unfortunately this is wired up into the rest of the whole box is all wired down into this thing. So I guess I'll just count. So ground, ground, VN, ground, ground, 5 volt. So VN, ground, ground, 5 volt. It's the 4th pin. Where the Arduino, I think, is getting most of this power actually from the USB connection that's back there. Oop, let me reposition this again. But This is just so they have a shared 5 volt. Otherwise, you get really weird signal problems. Okay, let's do the same thing for ground. So now I want to straighten out these. Smooth out these wires that I'm reusing. I have the one that I used to connect the power supply from the Pi to the Arduino. Get them all together. A little bundle. And then twist them together. And then finish twisting them with a tool. This one went together much better than the last one. Plug it into one of the ground pins of the Arduino. Coerce it to go into that little plug. I just heard the sound of something falling off. A little piece of metal fell off of one of the wires. I gotta brush that out of there, otherwise bad things will happen. Bad things, which for me usually means smoke. And smoke is bad when you use electronics, because then they stop working and then you're sad. Having a hell of a time getting that thing in there. Okay. Hey, went in that time. All I had to do was curse. Mild internet language. Now, remember how I complained before that it was all tangled? Now I need to get I wish I hadn't made these so close together. Lesson learned. But that is exactly why I have these forceps here. So I can shove those wires down into there. Okay, so now if all was done well, it should still turn on. So I guess we can check right now. I have the plug right over here. Let's see what happens when I plug it in. Is there anything that could be bad in there? Nothing looks too bad. Let's give it a spin. Boop. Hey, all the LEDs that I would expect to come on are actually coming on. I hear the servo motor spazzing out a little bit, which is surprising because it's not getting the signal anymore. I guess that's just it making the noise it makes when it powers on. And then all looks good so far. So this is actually in the wrong pin. So let me put that into the right one. Whoop. Which you should never do while your device is powered on. And then we just have to fix the servo motors, thing, which I actually don't even remember where it went, but that's okay because we have code. We have code to answer that question. So let me shrink this down and bring up the code for this project. This is art.js. Let's bring it up in Vim. Whoop. We have Vim over here. And we can see that the continuous servo is on pin 3. And pin 3 is indeed vacant in our actual physical project. So let's go ahead and fix that. In, of course, another terrible way. So let me rotate this around so you can see in there. So what I'm going to do is, this is like, I don't know, I cut up a jumper wire to use for this. I don't know why. I'm just going to do the same thing. So I'm going to cut the top off the jumper wire. And I don't want to solder in here right now because I don't have the proper fume evacuation stuff set up. And I'd love to keep drinking coffee at this table without fear of death. So I am going to splice the wire. Oh my gosh. Which for this kind of project is probably fine. So get some heat shrink tubing. Little section of heat shrink tubing. This is a stranded wire right here. So we're going to go ahead and twist it so it's no longer in the way. And this is another thing that forceps are really useful for. Just grabbing this kind of thing and twisting it around. Then what I want some solid core wire, preferably in a similar color, which I don't actually have. So we'll use blue. And I'm just going to make another little poker so I can poke into the Arduino. So I'm going to get a big old chunk of wire for doing the splice. That's too much. And then a little more than 1/4 inch of wire for the, looks like about 1/3 is what I ended up stripping off to plug into the Arduino. So I'm going to splice them together. I don't know how well this is actually going to work, but I'm sure it'll be fine. So I'm going to twist this wire so that one twists together. Whoop. And then I'm going to twist this one, twist the solid core so that it hooks together. And then I'm mostly going to be relying on the heat shrink tubing to hold it together, which is probably terrible. Let me squish down the solid core wire a little more. Also, because they're both like they're both from different jumper kits, like the gauge of the wire is way off. So the stranded wire is much, 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 much thinner than the solid core wire. So it's a pretty awkward connection. And I have a feeling that's going to be a source of woe later on. Go ahead, we'll just slide that on for now, and I'll shrink that tube down off camera because I want to drag this thing out to a place where I am comfortable heating up the world. But that might work well enough for at least the next, for the rest of the demonstration, for the rest of the hacking for today. Great, okay, so we have that wired up. I guess we should put the new software on there and see if it runs. So I have my SD card reader right here. I still have a device driver that I downloaded for all the awesome stuff. Where am I gonna plug this in? Because the thing is, when you have a bunch of cameras pointing at you, you use up a lot of USB ports. So I'm trying to find, where does that one go to? That one goes to my microphone. I probably don't want to unplug that, because I'm actually out of USB-C ports right now. Which means I could either find a different one, or I can unplug the power and see what happens. Let's unplug the power from my laptop. Let's see what happens. This could be terrible. Hey, the world didn't catch on fire, but it might catch on fire when I plug this back in. So we're going to go ahead, we're going to run off of a lower voltage power, or lower current power supply for the moment. Now what I'm going to do is I'm going to take the document projector. We're going to close that for now. Whoop. Document projector is gone. And I'm going to move the lights away. Shove all the cameras out of the way so I can actually get to my keyboard. We're going to copy this software to the SD card. So I would expect this file system to already be there, but it is not yet. So it might be something I have to run. So what was that program I downloaded that did the driver, which I could go look at my old video and find out, but I don't think that's what anybody wants me to do today. So let's open a new browser. Whoop. Let's go find out. So here is the stack exchange question we found before. Paragon's EXTFS driver. So I'm going to go into super secret hacker mode while I get that started up again. And for some reason, my little SD card reader is not reading, and I'm unable to push or pull data from it. So I might end up having to go the network route. That is assuming that the Raspberry Pi knows how to connect to my Wi-Fi, which I'm not sure is actually the case. I think I removed all the Wi-Fi networks from it when I first got it working. But I can probably plug it into physical Ethernet and connect to it over that, which I think might be what we end up doing. Okay, so let's go ahead and I'm going to unplug that. We're going to give up on the We're going to give up on the actual device driver. We're just going to plug this card into here. And then we're going to try and connect to the Raspberry Pi over the network. First step is getting this into there. Boop. So for this to work, I will need another network cable. Should probably plug my laptop back into power before it runs out of juice. Let's see what happens. This could cause a disaster. Hey, nothing bad happened. I'm looking around the room for an Ethernet cable, and I see one over there. I'm going to take off my headset, and I'm going to go grab an Ethernet cable. I'll be right back. And then back. Again. So that's many runs to the tool room this time. So I'm going to move so right now I have the device right here. So I'm going to move it over to this little table behind me. I'm going to plug it in there, and we're going to work on it from there. Because I'm going to plug it, my network switch is over in the corner, which is this kind of pile of junk in the corner that I still need to like properly shelf. So let me shove all these components back into here. Whoop. And then we'll shift this up a little bit so you can see my little workspace down there. So what I'm going to do is I'm going to plug the Pi into my network switch, and then I'm just going to connect to it over the network. So assuming it boots up at all, I'll be able to SSH in, because I think I have an SSH key on there. Oh, I got my little microphone cable caught. So right now I'm just plugging in a network cable, plugging in the other end into the Pi, which in my wisdom, I made all the network ports face inside the device. So it's a bit of a contortion, as is the case with a lot of work on this project. So the conductors go up. There we go. So now I'll plug it in to power it up, and we will see if I can find it on the network. Which, if I could, would be rad. Otherwise, I might have to reboot to get that ext4 driver working so I can access the file system directly from my workstation. So even though if it's running the old code, it should still be talking to the Firebase real-time database. Hey, it's doing stuff. Hey, the little servo motor still works. It just spun on itself. So it seems like my connection and my toggle switch doesn't actually short anything out. This is all good news. So let's go on in and, oh yeah, for some reason the servo motor creeps a little bit every once in a while. There's still another bug I haven't really figured out yet. But that'll be, I've kind of made it a feature because I didn't have time to troubleshoot it before. But we can investigate that too. So let's go up here, figure out why does the server bug? Why does the continuous servo creep? We've actually finished some of the stuff. So we wired up the toggle switch. Wired up the toggle switch. Boop. We fixed the wire for the servo motor. So kind of our electronics rewiring is done, hopefully. Now we want to verify it. So let's push the new code. The real project. So we're going to push the real code to the real project. So for that, hopefully, let's see if I can find it. ifconfig. So 192.9, 192.4. These are the. So first I have to find the IP address of that, which I can either like nmap my own network, probably find it with ARP traffic. -C5. So grep 192-C for context 5. So basically I want to find the network adapter that's actually connecting me to the internet. And I have lots of network adapters. So EN0. So I'm going to use the ARP command. A-IEN0. Is that it? Okay, cool. So here we have Raspberry Pi. That is almost certainly the machine just behind me. So connection refused. That's disappointing. I might have turned off SSH entirely. Which wouldn't surprise me because the network was noisy last time the project was demonstrated. So we have some other hosts that don't have a host name. Connection refused. That's going to find the same ones. Oops, that's not actually a valid host name. Just in case it is somewhere out there. So it's running, but it is not accepting my SSH connections, which means I probably need to get that SD card thing working. So at least I can turn SSH back on. So let's go ahead and get that network card out. Or get the SD card out. Oops, I just dropped it. Sometimes these things can be kind of delicate too. So this little SanDisk 16 gigabyte. And let's try this again. Let's just hope that if I plug it all in again, it'll just magically work and I'll be able to access the SD card. Nope. Okay, I might need to reboot to get access to this file system, which is a bummer. Or I can image a whole new card and push the code to it. That is another option, which will take longer than rebooting. So I'm probably just going to reboot. So let me go into super secret hacker mode and see if I've messed up anything in kind of my system preferences for this. But I don't see any problems. So I'm just poking around to see what's up with it. Okay, so I don't see it anywhere. So I'm just going to restart. I will be right back. Thank you for hanging tight. Now, if you're in there, like if you're hanging out, chat with me. I love seeing people chat. It's fun. But it'll take me a couple minutes to get everything going again. So see you in a couple moments while I restart my computer. And I am back from the reboot. I took the opportunity to start to twist wires, but I forgot how fast modern computers restart. That was really fast. I am so impressed by modern computers. Oh, and my background changed. There's like Large Hadron Collider behind it now. So it came back and hey, look, my EXTFS partition is there now. I'm still a little curious why I can't SSH into it. I don't know why I disabled that, but I did. There was probably out of paranoia because I knew there were some hijinks on the network. There seemed to be some hijinks on the network at the time that the project was originally demonstrated. The debut of this R project, not the second showing. So, but this is great because it means we can put code on here. So we want to go to aptly named untitled. And the way it's set up right now is it'll automatically run. Actually, does it have the get information here? I can probably just git pull. That's pretty cool. Configuration specifies from remote, but no such ref was fetched. What? Oh, hey, there's actually a whole repo for this project. So over here is actually the git configuration for this. And there's an origin. Okay. But it's set up all different from my git perspective. I kind of screwed that up. So what I'm going to do is copy the code over to it. Just to get it working, just to verify that it's actually running. I'm going to run this through a cycle. I'm going to plug it in, which is kind of a long cycle to do dev. It would be great if I could just push code to it. And we'll figure out a way to push code to it. It would be neat if I could have it like just pull from head whenever it pull from the master branch on GitHub when it restarted or something. But we won't do that. Hey, there's activity on the chat. False Park Location says, hey, what's up, Jen? Hi, False Park Location. I'll just call you FPL if you don't mind. False Park Location chatted with me last week too. So hi, it's good to see you. And not much is up. I am continuing work on this project. Just about to do a test run of it. So let's go ahead and do that. Let's see if our little toggle switch. Oh, iTerm's using it. Let's eject this file system. and go ahead and give it a spin. Roll over my power cable, which I'm sure is great for it because USB-C cables are not delicate at all. You know what would be cool to add to this project someday? A power switch. It doesn't have that yet. I guess the easiest way to add that would just be to put it on the inline. So it's actually starting a Raspberry Pi, so it takes a moment to start up. But if all is good and it runs that program, art.js, we should see it respond to toggle switch. So let me switch over to talking head mode, which also incidentally has this mode. Do I see the little things blinking? I see little LEDs blinking inside of there. So let me rotate it around for slightly easier seeing on your part. Let me tilt my webcam down a little further. Someday I'll get a real, like, proper tripod mount for that camera, and I'll be able to reposition it a lot more easily. So the question is, what is on that wallpaper on my computer? Is it something from the aerospace industry? Kind of, but not really. So if I go back to my live view, I have a whole bunch of pictures, mostly from astronomy and science. This is part of the Large Hadron Collider. I think it was early in the assembly of one of the big detectors. So it is one of the major instruments on the Large Hadron Collider, pretty early in the assembly. You can see people working in there, welding and stuff. Yeah, it's just science photos I picked up over the years, which has been fun. So my thing does not seem to be powering up all the way, or it thinks the LEDs are on a different pin. Did I move them? So what are they on here? So the LEDs in this one are on pin 4. In other words, what did I screw up? Why did you not power on? Let's give it a second try and see if it magically comes back to life. Yeah, the central part of my background was indeed hidden by a terminal window, full spark location. An excellent opportunity to drink coffee. This one is an old mug I have from a Girl Geek dinner that was hosted by Google many years ago, like I think 2005 or something, back in the day. So I see little LEDs coming on. I see blinking lights. What I need a second workbench in here so you can see that while I do that. I think I should probably set that up. But then the room will start to fill up rapidly. Oh, but then I'd also have a place to put workbench or tool benches. That would be pretty cool. Yeah, I don't know why the LEDs aren't coming on. I think I actually have to get a network connection working. So let's go back to this. Let's see if it actually booted up far enough to get an IP address. You can see all the MAC addresses of different things I have on here. So here we go. There's something on the network. Connection refused. So why did I kill the SSH daemon? So, but it booted up far enough to get an IP address. So you get to witness me do some troubleshooting. So I'm going to power this down by unplugging it. I'm going to pull out that card, and I'm going to try and turn SSH on by finding the right file on the file system. But the fact that it's booting up far enough to go fetch an IP address is promising, because it means I didn't cause a catastrophic problem with the operating system or anything like that. So if we go to so where would that be? That would be in root etc, and then how would I have disabled SSH? So either I turned off the SSH daemon entirely, which would be, I don't even know where that would live because I'd use the service command normally to turn that on and off. Where else might have I stashed that? Well, let's see what I would have done. Tracing my steps of past me is I would have gone and whoop. I probably would have searched for something like this: disable SSH Raspberry Pi. Use the Raspberry Pi config command in the terminal window. I certainly hope I didn't do that. I wonder. I wonder what it actually does to change that. Oh wait, am I supposed to like SSH into root or something insane like that? I didn't get connection refused. Oh, I'm cropping the bottom of my terminal. So so if I SSH in pi at, I get connection refused, which is, oh no, I'm getting nothing. Oh, because it's off. I'm an idiot. That's why it's like just going into ether. Hey, there's Slayer Darth. Hey Slayer Darth, how's it going? You seem not to be streaming from your usual spot, Slayer Darth reports. That is correct. I have moved to a new location. I have a place with controlled lighting and, more importantly, controlled temperature. Because although I had wonderful windows right in front of me before, it would often get very hot. And that would make me sad and make me stupid when I was streaming because I was spending too much brain power trying not to overheat. So I'm in a back room in my place, which was previously... It's also the guest room, which is another reason I don't want to solder in here, because I don't want to poison my guests. So... how did I disable SSH on my Pi? I'm going to be bummed if I just have to make a new image. Because the other option is I can pull the Pi out and actually plug it into a monitor. Disoc says, what are you working on? Hi, Disoc. I am working on this thing. I will send you a link to it. This is a link to, basically this is the original art proposal for the project. Boop. And there's also a YouTube video of the prototype working. I should probably set up a bot so I can have those auto reply really easily. But if I go to my own YouTube channel, hey, I can see that I'm streaming right now on YouTube. That's crazy. But I can also see this video of the thing running. So the first link is the proposal when I originally submitted it. And then another link is the original prototype operating. I'm doing some upgrades on it for another art show. But essentially, it's electronics, JavaScript, and fun. And right now, I'm struggling with the fact that in a drunken haze, I locked down that Raspberry Pi. And I need to get back into it because it's not working, and I don't know why. It's probably something dumb like permissions. Let's just troubleshoot some obvious things. So Slayer Darth reports that you returned to work after taking a month or two to work on my side project. What side projects did you work on, Slayer Darth? He reports that RMRF/ will fix it. Yes, that would fix it a certain way. But not the way I want. So here's the file system. And so Disoc mentions, is there an SSHD config in there? There is an SSHD config. I just don't know. I probably use the Raspberry Pi config program to disable it, and I don't know which file that modifies. But probably, maybe SSH config. Let's find out. Because I could have just disabled like SSH login here. So what all is in this file? It's been a while since I've actually looked at one of these. I've not had my site reliability like sysops hat on for a very long time. But it is a fun hat to have on sometimes. So Darth was working on a portfolio site. Radio station, XML feed aggregator, e-commerce, app, and Rails. Cool. I haven't done Rails development in a long time. It is fun. Is it currently running on boot? Yes. The Raspberry Pi is starting up and it can get an IP address. And, but I can unplug the file system and look at the file system. I can just plug the SD card into my computer. But So I can modify files, but I can't connect to it over the network, so I can't see the processes as they're running. So what I'm probably going to do is just reimage it, because then at least I start from a known state instead of mystery state. But it says SSHD is running on port 22. It is permit root login without password. Okay. Our pub key authentication. It looks like this looks like the default configuration. So got a no, maybe the status. So it sounds like the SSHD daemon isn't running on boot. That is a likely scenario. The SSHD daemon is probably not running on boot. So probably in here somewhere, but I don't know how to modify which services are running from the file system, because I've always used software to do that for me. There's README. Yay, stuff. Yeah, so it's probably handled from sysinit. Is that a file? No, it is not a file. It is probably a process, which is being started from somewhere in the kernel or something. So J45RKU recommends I try as root. I am going to try. I'm going to try SSHing as root. We'll see. I don't think it's accepting connections on the port, because I can't even get like a verbose SSH output. So Disoc mentions I should sudo raspi config, but that would be assuming I'm running on the Raspberry Pi right now. I just have it plugged into my Mac, the file system. So all I want to do is run. There's only like 2 files that are different from the original system. So I'm going to take the opportunity to upgrade. I'm going to go slurp down a new, because I think this one's still running like Wheezy or something. I think this might be a good time to, what would you call it? Install some patches. So what do I want off of it? I'll pull what I want off of it now, which is, So I'm going to go copy of, I think I have an rc.local. It has a couple lines in it. So I'm using that. Oh, could I use it? Could I start the SSHD from rc.local? That's kind of crazy. Let's ask the internet. I'm going to run a command to restart that, but I don't have interactive. So, is there a non-interactive command I can use to do that? Probably, but I don't even know the search terms are used for that. Well, okay, I will do this. I'm just gonna go grab an image. There's like a slim image, right? Raspberrian. We got a bunch of other images. Stretch light. Okay, let's download the zip. How big is this file anyway? Oh, it's only 900 megs. That'll be down in just a moment. Nerd question. What keyboard are you using? I got this mechanical keyboard off of, I got a mechanical keyboard. What is it called? I have the Drevo keyboard. I got it off of a colorful LED lighty keyboard I got off of Amazon. It works okay. The Alt key I'm having trouble remapping. So if you mount it, then you can see root and run command. Does SSHD randomly stop running at boot? That's no fun. So the background on this is there was a period of time where I was off of the internet, but I was on a network with a whole lot of noise. Terrible noise. And I started locking down processes because there was a lot of fishy stuff happening on the network. I was actually in the woods when this was happening. And that's probably when I messed up this Raspberry Pi SD card image. So that was when I caused that problem. But that's okay. And yes, I just got distracted for a moment, and now there's people in here. It's great to see so many people chatting. This is a new thing for me. I've never had more than a couple people hanging out in the chat room. So thanks a lot for hanging out and chatting and watching me download a Raspberry Pi image, which I know is not the most exciting thing ever, although it is only 87 megs in. That's like 10%. This might take a moment. So while that's going, I will do both options. What else could be going wrong? So it was recently just starting up. So let's go back. I can write something to, what I'm going to do is I'm going to have it try and tell me a little bit more. So while that's downloading in parallel, what I'm going to do is I'm going to add some stuff to the card. And I'm going to see if I can get it to tell me a little bit more about what's going wrong. So let's see if there's a single command I can, like, enable SSHD on Jesse. I think I'm actually running Wheezy. Everyone takes you back to that interactive config command. The last time I actually did sysops type stuff was on Solaris. I know it's been that long. Okay, so is that still downloading? Still downloading. So in the meantime, I'm not going to try and start the SSH daemon. I'm going to go into my program, make sure I didn't screw anything up, like on permissions or anything. Still looks fine. Then I'm going to see, the credentials file. That's what's up. I bet the program is crashing because the credentials are wrong. So I'm going to go into, so I bet it's sitting there just freaking out because the credentials are wrong. So I'm running off of Gotchaception. What I want to do is I want to go get some credentials, and we just moved this to a new location. It was so much better than the old one. There's my email address. I am very satisfied. So where did we stick that? If I want to go create a service account. Here we go, service accounts. So I want to generate a new private key. Generate a key. Don't show this to anyone, obviously, if you ever do this. And I want to copy this to /credentials.json. Is that what I'm reading off? That's what I'm reading off of. Okay, so there's a question from riddlere_. Do you have any thoughts on coding boot camps? I love coding boot camps. I think that software development is a skill that no matter what industry you work in, no matter what you do, will give you kind of the superpower ability to automate some part of your job. So I think they are great, but I think sometimes they promise more than... They promise an easy path to software development job, but the truth is software development work is hard, primarily because it is fun. And because it is fun, people do it in their free time or work extra hours, which means you're competing against people who are working really hard. So if you want to be successful as a software developer, you have to enjoy coding. You have to be willing to work really hard. But coding bootcamps are certainly a way to up your game and get there. I've seen people who have a history in other similar fields like science education and stuff have been able to use bootcamps to do a career switch. But really it depends on what you're trying to get out of it. If you're trying to learn the skill of coding, they will certainly teach you to code. But there are other aspects to like software engineering or being a great front-end developer that a lot of that comes from other parts of experience. But yeah, I totally agree that being kind of project-centric in approach is something that other people in chat are mentioning. Having projects I'm working on, which is one reason I work on silly projects like this, can certainly make it easier to advance your skills. So, all right, let me go ahead. I think that might fix this thing because I'm still downloading that image, which is my plan B. Hey, downloaded that whole image because programs are using it. So where am I using it? There we go. So let's go ahead and eject that. Now that VI is closed, let's go back over here. Let's plug it in and see if I've magically fixed it by guessing the problem, because the credentials are certainly messed up. But let's see if this magically fixes it. Yeah, the chat's discussing right now being, I should just bring it on screen. Oop, I've never done this before. Hey, you're all on my screen. Please be civil. Yeah, one of the cool things about boot camps is they teach you that skill, but having that network is an important thing, which is something I hear from like just education overall. Like a big part of my value that I got out of my education was the network that I got from it. And this seems to happen across the industry, whether you're getting a Stanford MBA or doing a scrappy bootcamp program. The friends you make in that program and your ability to work together are super useful, and they are just as significant an asset as any skills you build up. So it is blinking. ARP-A and 0. Can I see the pi? Hey, the pi is there. Someone mentioned I should try SSH-ing as root, which seems insane. Seems my node process is still grumpy. But let's get that IP address again off of ARP. So I don't think this will work because I think that port is closed. Because if I if I do that, I don't have telnet, but I have telnet. If I just try and establish a TCP connection to that, it goes beep, refuse, which means the SSHD daemon is not running. But yeah, I don't think it's going to come on. So there is still something wrong with my process. But I do not know if I want to re-image it. I don't know if that'll be faster. I'm going to take a couple more swings at kind of random troubleshooting of things I've probably broken. Or I could also roll back to an older version. Let me use the forceps to pull out the SD card carefully, because these SD cards break sometimes. And that would be really sad, because I don't even know where I have a spare one. Fortunately, I use pretty small SD cards for these projects, which is great, because you can copy them really fast. Okay, so I have this partition, or I have the thing mounted again. Let's go take a look. So what is kind of our path of execution? So if I go to so rc.local is running the script called forever, and it's running art.js. So so I have credentials. Are they from the right place? Probably. Actually, I'm going to make this even easier. I have credentials I have this gacha game section directory. I'm just going to copy the whole gacha game section directory. CP. Oh, but it's going to have all the... Oh, that won't work because I'm doing dev on x86, and I'm sure there's some node dependencies that are building from source. So we're building some like C stuff. Let's see if that works. -r. I don't know if this will actually work. Snippets, gacha gameception. Boop. Let's see if this works. So I'm copying all the node modules and everything else over. Input output error. That's weird. Why are there IO errors? That's probably the result of the driver I'm using. That is unusual. Okay, this is getting too weird. I'm just gonna copy that image over. So, I'm just gonna copy the rc.local I had from here, from the SD card. And so if I reimage it and I don't have access to a screen, will it still be able to work? Let's find out. So what I want to do is eject these disks. Boop. I want to unzip the stretch image. Then, and yes, I love MacVim. And someone mentions I should SSH into a known server to know it's not an issue with my local SSH program. So I think I've probably already eliminated that case by trying to telnet in and knowing and getting the connection refused. Because otherwise, I'd at least get at least get it closed. It wouldn't just refuse a connection. But I could. What do I have an SSHable host that I can SSH from the keys I have on this system? I actually don't have any handy. But we're going to be able to verify this real quick. So, so how do I list this devices? Pi, copy SD card. I'll ask the internet like I always do. Is there any... There were instructions in here I saw. Boop. For advanced control of this process, system-specific guides. Let's see how I get my list of disks. And if I remember right, I want to make sure I go to our disk. Yeah. So, how do I list all my devices? Disk util list. Obviously. And does it, okay, so disk 1, that is that one. That is like, it looks like a recovery file system. That's my disk 0, and then I have a virtual disk. That's interesting. Oh, it's probably because I have full disk encryption set up. So let's go ahead, reconnect it so that the disk shows up, and then I want to unmount them. Oh, disk util can unmount disks. That's pretty cool. Yay, okay, but it's still there, right? Yay, it's still there. So now I can copy a base image to it. And this will take a moment. Let's make sure I don't wipe out my system while I'm going. So boot is a fat file system. What is the conv equals sync? I've never used that one before. Such an old program. And conv equals sync tells DD to pad each block to the left with null so that if due to an error, the full block cannot be read, the full length of the original data will be preserved. Oh, that's pretty cool. It's always funny when there's a command, like that's an ancient utility, and I've never seen that part of the command. Okay, so that's going to nuke the old one. Looks like a clean command to me. And if I remember right, I can ask it. Yay, I can ask it how it's going. So that's going to be going for a few minutes. And thank you, Slayer Darth, for giving my friend the Kraken a heads up on what I'm working on. Yes, I'm working on a capsule toy machine that will be hooked to the internet. Well, actually, it has been hooked to the internet in the past. Right now, I'm upgrading it, which of course means working at lower and lower levels, breaking things that were previously working. Right now, I'm taking a huge step back, and I'm re-imaging the SD card, which is a 1.8 gig image, and we've copied about 560 megs, so we're making pretty good progress. And Slayer Darth reports, I am disappointed. You have GIMP installed, and you could easily use Sketch. I also have the full Adobe Creative Suite, but I have encountered a class of objects on the internet that I've only been able to open with GIMP. So GIMP mostly exists for me as a free image converter between some more esoteric formats I've encountered. And it's good for that. Although I can't, I love GIMP, but I just can't get my hand around the dev flow. I'm hooked on Photoshop. One of them people. So I assume the first time I plug this SD card in, it's going to expand the file system or something like that. And then I might have to power cycle it to be able to SSH in. But the very exciting part of the broadcast where I copy stuff over is hopefully going to be done soon. Here's our database that we'll be working with in just a moment. I tried to install GIMP on my Office Mac, but it has to load all of your system fonts. Yeah, I never really ran into any font woes with it, but it could be I just didn't notice and I tuned it out. So how big is, so this one is 1.85 gigs, and we're at about 1.6 gigs copied so far. So we're almost there, and then you'll be able to see something that's actually exciting, I hope, if anybody's still around. Hey, it mounted. So let's go ahead and eject these disks, plug it in, and see if it can connect to the network. Boop. And if it can connect to the network, then I'll be able to SSH in, copy all the data over, and everything should just magically work right away, right? Let's find out. So I imagine it's going to get the same IP address when it comes back, because it's the same MAC address, because that's off hardware, I assume. So we'll give it a couple minutes to start up. I see the little LEDs on the network device blinking now. And then let's see if I can get in there. We'll give that a couple more minutes for it to come up. But hopefully I'm not in any real trouble, because if I've broken this thing, I'll be sad because I have to have it working this weekend. So there's a host back there. And that's definitely the only Raspberry Pi that's plugged into my network. So why can't I SSH into it? Let's see. So maybe, well, it's plugged into 2 network adapters right now. Maybe, because we also have, we have EN0 and we have EN13. Dash A dash I EN13. Is there another Raspberry Pi there? Cool, there is another. So that's it's plugged into the physical network. Because the other one I think is my wireless network, which I have on still. But connections refused on that adapter also, which is surprising. This is the bummer part where I might have to pull that out, plug it into an HDMI device and see if it's actually working. Because doing these things completely headless can be kind of a pain sometimes. Bummer. Well, I'm going to try power cycling, because if I remember right, it like expands the file system on the first boot. So maybe it didn't actually start anything. I see Format is starting on the Arduino blinking. Otherwise, this might be the kind of hacking I have to do off camera, because it involves lots of running around to different places and moving things up and down. So let's see, is there any new hosts on that? Nope. But still connection refused, which is kind of weird. Give it a moment to do its boot up cycle. Let's see, let's actually make sure that I'm connecting over the right network, because now it definitely won't know how to get to the wireless network. So I definitely want to do this one, and this one is the one that has IP 1044. And so EN13 is the one, this is the hardwire network for sure. Yeah, but connection refused still. Because it finds it, so when I unplug it, it just hangs. So it's definitely getting to that piece of hardware. It is just not finding its way in. Maybe we'll try SSH inning as root. But yeah, I think this is going to be the case where I have to tear it out, actually plug it into a physical device, or plug in a different Pi into like a monitor that accepts HDMI, which is basically going to be my TV. And then we'll get back to the rest of this stuff later. But yeah, I wouldn't be getting connection refused if it's just a matter of which user's working or not. That is a bummer. Is it because of the image I picked? So I picked the long-term support slim one, the light image. So we went to the downloads page and we got Raspberry. We got Raspberry Stretch Lite. Is SSH enabled by default? Headless setup procedure. Hey, this is exactly what I'm doing. The Wi-Fi network. Okay, that's how to tell it about the Wi-Fi network. I don't need that so much. So create an empty file, just name it SSH, save that empty file, and dump it into the boot partition. So apparently there is SSH activation file I need to put in there. Let's go ahead and do this. Let's see if the internet has answered my woes. Put files in a directory called boot. So there's a partition labeled boot. And this needs a file in it called SSH. Let's do all the permutations of things they describe. So we have here. So it's just saying that if you drop a file into the boot partition called SSH, it should just like start SSH up like magic. Like there's something in there that goes and pokes it based on my superficial reading of that path. So let's go ahead and give that a try. Whoop, let me drag that off. So stdio.h asks if it's something with my SSH config or known hosts. I would be getting a different, so if it was a problem with those, I would be getting, the SSH command would be saying like, hey, something's up. But I can certainly go SSH into a different host if we want to verify that that stuff's all working. But for now, we're going down there, we're letting that run again, we're letting it boot up, and hey, it's not refused immediately anymore. This is a good sign. This is exactly what it would say if it was a known host issue. So I'm going to go into super secret hacker mode to fix that. So what is the host? Let's try going in as pi. Okay. Hey, I'm SSHing in right now. This is exciting. I'm actually finally getting connected. Yay, the password's still default, which would be a disaster. Actually, I want a different password. So, and I'm not going to make a correct horse battery staple. I'm going to make it something else. This is the first thing you should do whenever you set up a Raspberry Pi, by the way. Like, disabling password-based authentication is cool. But you should at least change your passwords, the root password and the Pi password. So, yay, okay. So that's not going to get pwned immediately when it touches the network. So now I'm going to install Git. Then I'm going to generate an SSH key, add it to my GitHub account, which I'll do off camera when that happens. What are you all grumpy about? My apt-get is all confused. So I have to update my apt-get. All the fun things you do when you first get a new image and start setting it up. Because apt-get always has a bunch of like old places it goes to get packages. So let's update Git or install Git if it's not there. Now remember, installing Node is a little weird. I wonder if it still is. This ancient entry. So, oh, I should just be able to apt install Node.js. Cool. So I need to add a source to it. That doesn't, that's always a little bit creepy. Why not? Let's do it. Our friends at No Source maintain an excellent distribution of those binaries. Because, you know, this is always a terrible practice. Never pipe random files from the internet to bash, but it doesn't look like it did too much damage. So then we'll install Node.js. So let's go ahead and install that. Then we're going to put another one. This shell is connected to my local system. So then we're going to grab, oh, I need to npm install Forever. Because Forever is a node program I use that restarts, kind of like lazy service. If this program ever crashes, it'll automatically restart it. And it works pretty well when dumped into an rc.local. So, permission denied, user lib node modules. Why is it installing a user lib? I'll just install it as root. That way I'll have to run everything as root. Sure, go for it. It's a single user device anyway, essentially. Yeah, because the way Node is set up, it's user lib. I don't want to like change a bunch of permissions on usr lib. One of the weird things that happens when you take essentially a multi-user system and put it in an embedded device is it's essentially running as a single user, kinda. Hey, Forever is there. Neat. Okay, so now install Vim. So go ahead and install that. I'm really glad we didn't have to get to the point where I pull it out and plug it into a TV, going one step down of the stack each time there's a problem. At the very least, I do have a pretty fast internet connection, so this stuff is slurping down reasonably fast. So next up, let's go ahead and modify this. Let's add the, modifying is read-only. Let's modify it as root. Let's go ahead and copy this line out. And let's, yeah, this is fine. So go into Gotcha Gameception, which I hope we spelled the same way. Gotcha Gameception looks about the same. And now what I need to do is SCP a bunch of stuff over. Do I have rsync? Yay, I have rsync. Okay, so -vaz./* to this host. Pi at .local colon so let's rsync all that code over. And it is grumpy. Permission denied. Because I typoed my password. Copy the whole world over, most of which is Firebase dependencies. And we'll see if any of this has like a bunch of weird C stuff that's like specific to the architecture. So the question was back, any luck? Yes, we got SSH'd in and I copied a bunch of stuff over. Let's see if I can run the program now. And it says that it is grumpy. Because invalid ELF header. It sounds like there's something in the node modules that I copied over, hoping it would just like magically work, because everything is just pure JavaScript, right? Do I actually have a package.json? I do. So I should just be able to npm install. And then node art, and it should just work. Once it installs all the other stuff and builds a few things from source code and does all the dancing that it needs to do. What version of Node am I running? 6.11.1. What version am I running here? At no, which node? 8.9.1. So pretty different version. How did my desktop node be so far behind? We'll see. I'm assuming this will probably work. 2 major revisions. No one ever has any breaking changes in major revisions, right? We will see how well that works. And it got a little grumpy. Pre-built binaries not found. Oh no, explosions, explosions. As it tried to build some dependency. Thanks, Slayer Darth, for letting Adderfer know what I'm up to. So, I don't know if this actually worked. I saw a bunch of errors and stuff. But it said it didn't, it looks like it worked. Apparently all of those, hey, what do you know? Okay, so let me point the camera down at the actual project. It's starting up and working. We have the new sparkly lights that look nice and stuff. And now if I toggle the toggle switch, it should trigger an event. And the redraw when it toggles the toggle switch is a lot slower because I have to clock out all, I have to rewrite all of the pixels instead of just making them move around. That's pretty cool. Okay, so we got as far as that thing is actually working. And what's really cool is the, it's still logging out. With the way I rewired the toggle switch differently, and it gives me a much cleaner signal. Okay, so let's go ahead and let's see if that actually starts up a boot. Okay. Let's see if that's actually capable of starting at boot instead of just running from my system like I told it to. And Slayer Darth reports, maybe it'd be a good idea to have a chatbot with a few useful commands like bang project. I think that is a great idea. and it's probably something I should do next. Like the whole thing I got started. There was another streamer, Noobcat, who wrote a wonderful blog entry on things I learned from a year of coding on Twitch. And she was one of the inspirations for me to pick up this project, streaming on Twitch in general, a few months ago. And just one of the things she mentioned is that it's a good idea to have a bot to help with that kind of stuff. And it seems to be working pretty well. And it's not that hot. It only smells a little bit like fire. The important skill of electronics. Like, smells a little weird. Slayer Darth reports, I can write for you if you want. If you have a bot, I know that there's already bots out there that people are using. I'm probably just going to pick up one of them. But if you have a recommendation, I would love to hear it. Cool. So it's actually working. And the cool part is it starts up right at boot. And I don't think it needs to know much about the network connection right now. And although I do smell an angry cap. That's how you know you've been around electronics a little bit, is you know what things smell like. So I think something probably, I have one cap that's in line on the power supply. I'm going to bring the whole thing up and I'll see if that persists. It's okay, I have a fire extinguisher handy if everything catches on fire. Slayer Darth reports, Nightbot is pretty nice. Yeah, I'll give Nightbot a spin. But something's definitely up. Let's see if, where does that cap live? It's back in here somewhere. Is it hot? No, it's not hot. Oh no, I see where it came from. Okay, I'm gonna unplug for now. The servo motor is sad, but we'll get back to that later. So, I think on that note, it is starting again. I think things are pretty happy now. I got the project flipping back and forth. Sorry I didn't zoom in on it much, but I'm actually out of time for the day. So I am going to wrap up for the day. So let's go back to our little task list. Twitch to do, and let's see what we did. So we spent a little bit of time fixing up the electronics on this project, and that went pretty well. We verified it, which we spent the rest of the entire time on, which was rebuild all the things, because it was pretty broken. Then we never had time to dig into why the continuous servo is creeping along. Or spend time doing software refactoring. I think those are going to wait for a future session if we decide to keep cracking away on this. Also, I found a cool state machine implementation in JavaScript, which is probably a good way to handle the overall movement of the stuff. And then finally, the whole point of it having hooked up to Firebase is to have a management application that we can use. Although I'm not sure it's actually even going to have a internet connection at the next event it is being shown at this weekend. So this can go on the back burner for a future stream. So on that note, thanks a lot for all of you who tuned in, and thanks a lot for everybody who participated in the chat and kept me company while I struggled with reimaging the Raspberry Pi and getting it to connect to SSH. It was a frustratingly fun encounter with my system administration hat. So thanks a lot. Have a wonderful rest of your day, and see you all next week.